Srinivasa Ramanujan Iyengar was an Indian mathematician who, despite having had no formal training in pure mathematics, made substantial contributions to mathematical analysis, number theory, infinite series, and continued fractions, including solutions to mathematical problems then considered unsolvable. He was born on 22nd December 1887 in Erode to K. Srinivasa Iyengar and his wife Komala Dammal. He started his schooling in 1892. Initially, he did not like school. However, he soon started excelling in academics, especially mathematics. In 1803, he got his hands on a book titled A Synopsis of Elementary Results in Pure and Applied Mathematics by J.S. Carr, which was a collection of 5,000 theorems. He was thoroughly fascinated by the book and spent months studying it in detail. This book is credited to have awakened the mathematical genius in him. In mathematics, there is a distinction between insight and formulating or working through a proof. Ramanujan proposed an abundance of formulae that could be investigated later in depth. G.H. Hardy said that Ramanujan's discoveries are unusually rich and that there is often more to them than initially meets the eye.
Aryabhatta. Aryabhatta was the first of major mathematician astronomer from the classic age of Indian mathematician and Indian astronomy. His work includes the Aryabhatiya and the Arya Siddhanta. For his explicit mentioning of relativity of motion, he also qualifies as a major early physicist. His contribution. Aryabhatta was an Indian mathematician and an astronomer who is regarded as a towering figure in both these fields. Some of his work has been lost through ages, but his influence may be seen in the work of succeeding Indian mathematicians, who frequently refers to his work. Among other things, Aryabhatta calculated the closest approximate value of pi till that time and was the first known person to solve Diophantine equation, and also was the first to explain that moon and planet shine due to the reflected sunlight. He made major contribution to the field of trigonometry and algebra. He most probably understood the concept of zero and place value system. He made incredible accurate calculation of the length of the day and the year. He explained how moment of celestial body was due to the rotation of Earth. Brahmagupta. Brahmagupta was an Indian mathematician and astronomer. He is author of two early works on mathematics and astronomy. The Brahmasputara Siddhanta, a theoretical treatise, and the Kandakahadya, a more practical text. Brahmagupta was the first to give rules to compute with zero. His contribution. One of the most significant input of Brahmagupta to mathematics was introduction of zero to the number system, which stood for nothing. His work, the Brahmasputara Siddhanta, contained many mathematical findings written in verse forms. It had many rules of arithmetic, which is part of mathematics solution nowadays. In geometry, Brahmagupta's theorem states that if a circle quadrilateral is orthodiagonal, that is, has perpendicular diagonal, the perpendicular to a side from the point of intersection of the diagonals always bisects the opposite side. It is named after the Indian mathematician Brahmagupta, the year 1918 to 1668. Thank you. Presented by Gaurian Warrior.
Bhaskara II. Bhaskara, also known as Bhaskaracharya and as Bhaskara II to avoid confusion with Bhaskara I, was an Indian mathematician and astronomer. From verses in his main work, Siddhanta Shiromani, it can be inferred that he was born in 1114 in Vijalwith in Shandari mountain range near the town of Patan in western Ghat region in present-day Khandesh in Maharashtra. He is the only ancient mathematician who has been immortalized on a monument. In a temple in Maharashtra, an inscription supposedly created by his grandson Kangdev lists Bhaskaracharya's ancestral lineage for several generations before him as well as 2 generations after him. Colebrooke, who was the first European to translate Bhaskaracharya II's mathematical classics, refers to the family as Maharashtrian Brahmins residing on the banks of the Godavari. Some of Bhaskara's contribution to mathematics. Bhaskara too was especially well known for his in-depth knowledge of trigonometry. Discoveries first found in his works include computation of sines of angles of 18 and 36 degrees. Bhaskara too used letters to represent unknown quantities, much as in modern algebra, and solved indeterminate equations of first and second degrees. He reduced quadratic equations to a single type and solved them and investigated regular polygons up to those having 384 sides, thus obtaining a good approximate value of pi equals to 3.141,666, a proof of the Pythagorean theorem by calculating the same area in 2 different ways and then cancelling out terms to get a square plus b square equals to c square. Madhava of Sangamagrama. Madhava of Sangamagrama is an Indian mathematician from the 14th century and is also known to be a great astronomer. He was born in the Indian state of Kerala in 1350. Very less is known about the early education of Madhava, but his great contributions in mathematics and astronomy are still widely acknowledged. He is famous for establishing the Kerala School of Astronomy and Mathematics. Many of the mathematicians who came after Madhava and worked further on his discoveries have been found to refer to him and acknowledge his work in their publication. But most of Madhava's own work cannot be found today. Madhava did a lot of work and contributed to various subjects of mathematics. Madhava's contribution to mathematics. Infinite series. Trigonometric functions can also be expressed through infinite series. Many of these series were discovered by Madhava. The series that he derived and provided include Madhava's sine series, power series for sine, Madhava's cosine series, power series for cosine, Madhava's Gregory series or Gregory-Madhava series, power series for inverse tangents, Madhava's formula for pi obtained by expansion of power series for inverse tangents. These series, initially written by Madhava, as his successors shown in their books, later got rediscovered by mathematicians of the West who represented those using modern notations. For instance, Madhava's sine series and cosine series got rediscovered by Isaac Newton in 1670. By Anjana Case.
P.C. Mahalanobis. Prasanta Chandra Mahalanobis was an Indian scientist and statistician from Bengal. He is the founder of the Indian Statistical Institute, the architect of Second Five-Year Plan, and a close associate of Rabindranath Tagore. He is known as the father of Indian statistics. He is best remembered for the Mahalanobis distance, a statistical measure. Mahalanobis distance is an effective multivariate distance metric that measures the distance between a point and a distribution. He also contributed to the design of large-scale sample surveys. Some of his honors are Padma Vibhushan in 1968, Srinivasa Ramanujam Gold Medal in 1968, Fellow of American Statistical Association in 1961, and Honorary Fellow of King's College, Cambridge in 1959. The Government of India decided in 2006 to celebrate his birthday, 29 June, as the National Statistical Day. Satyendranath Bose. Satyendranath Bose was a famous Bengali Indian mathematician who did important work in statistical mechanics. He is best known for his work with Albert Einstein on the famous Bose-Einstein condensate, as well also being the namesake of the famous boson particle. The Higgs boson or God particle is believed to be the particle which gives mass to matter. He did important work in quantum theory, in particular on Planck's black body radiation law. Bose was able to derive the formula for radiation from Boltzmann's statistics. Bose published on statistical mechanics, leading to the Einstein-Bose statistics. The Indian government honored Bose in 1954 with the title Padma Vibhushan, the second highest civilian award in India. 5 years later, he was appointed as a national professor, the highest honor in the country for a scholar. About 12 years after Bose's death, the Indian Parliament established the S. N. Bose National Centre for Basic Science in Salt Lake, Calcutta.
D.R. Kaprekar. Dattaraya Ramachandra Kaprekar was an Indian recreational mathematician who described several classes of natural numbers, including the Kaprekar, Harshad, and self numbers, and discovered the Kaprekar's constants, named after him. He became well known in recreational mathematics circles. Kaprekar received his secondary education in Thane and studied in Fergusson College in Pune. In 1927, he won the Wrangler R.P. Palanchpe Mathematical Prize for an original piece of work in mathematics. He attended the University of Mumbai, receiving his bachelor's degree in 1929. He is also known as Ganidhanand. Contributions of D.R. Kaprekar. Working largely alone, Kaprekar discovered a number of results in number theory and described various properties of numbers. In addition to the Kaprekar's constant and the Kaprekar numbers, which are named after him, he also described self-numbers or Devlali numbers, the Harshad numbers and Demlo numbers. He also constructed certain types of magic squares related to the Copernicus magic square. International fame arrived when Martin Gardner wrote about Kaprekar in his March 1975 column of Mathematical Games for Scientific American. Today, his name is well known and many other mathematicians have pursued the study of the properties he discovered. C.R. Rao. Kalimpudi Radhakrishnan Rao, popularly known as C.R. Rao, is an Indian-American mathematician and statistician. He was born on 10 September 1920. He is currently Professor Emeritus at Pennsylvania State University at Buffalo. Rao has been honored by numerous honorary degrees and was awarded the U.S. National Medal of Science in 2002. The Times of India listed Rao as one of the top 10 scientists of all time. Rao is also a senior policy and statistics advisor for the Indian Heart Association non-profit focused on raising South Asian cardiovascular disease awareness. Contributions of C.R. Rao. The American Statistical Association has described him as a living legend whose work has influenced not just statistics but has had far-reaching implications for fields as varied as economics, genetics, anthropology, geology, national planning, demography, biometry, and medicine. His best-known discoveries are the Kramer-Rao bound and the Rao-Blackwell theorem. These both are related to the quality of estimators. Other areas he worked in include multivariate analysis, estimation theory, and differential geometry. He has earned various awards including the Padma Vibhushan. By Fatima Mehri, AP.
Harish Chandra. Harish Chandra was an Indian-American mathematician and physicist who did fundamental work in representation theory, especially harmonic analysis on semisimple Lie groups. He was born in 11 October 1923 in Kanpur. He was died in 16 October 1983 in United States. He is known for Harish Chandra's C-function, wheel character formula, Harish Chandra homomorphism, Harish Chandra isomorphism, Harish Chandra module. Wheel character formula. In mathematics, the wheel character formula in representation theory describes the characters of irreducible representation of compact Lie groups in terms of their highest weights. It was proved by Hermann Weyl. There is a closely related formula for the character of an irreducible representation of a semi-simple Lie algebra. In Weyl's approach to the representation theory of connected compact Lie groups, the proof of the character formula is a key step in proving that every dominant integral element actually arises as the highest weight of some irreducible representation. Important consequences of the character formula are the Weyl dimension formula and the constant multiplicity formula. Shakuntala Devi. Shakuntala Devi was an Indian mathematician, writer, and mental calculator, popularly known as the human computer. Her talent earned her a place in the 1982 edition of the Guinness Book of World Records. She was born in 4 November 1929 in Bangalore. She died in 21 April 2013 in Bengaluru. Shakuntala Devi attained universal fame when she demonstrated her ability to multiply two random numbers of 13 digits. Shakuntala Devi strove to simplify numerical calculations for students. She wrote a number of books in her later years, including novels as well as texts about mathematics, puzzles, and astrology.
Raman Perimala. Raman Perimala is an Indian mathematician, and for many years she was a professor at Tata Institute of Fundamental Research, TIFR, Mumbai. She is the Arts and Science Distinguished Professor of Mathematics at Emory University. She was born in 21st November 1948 at Mayiladuthurai, Tamil Nadu. She grew in an encouraging and progressive household. Her father was a professor of English literature and her mother was a constant pillar of support for the family. She studied in Sharada Vidyalaya Girls High School at Madras and Stella Maris College at Chennai. She received her MSc from Madras University in 1970 and her PhD from Bombay University in 1976. Contributions and awards. Raman Perimala is known for her contributions to algebra. She has been described as supreme and powerful algebraist. Early in her career, she published the first example of a non-trivial quadratic space over an affine plane. This result surprised many experts and has since led to further developments in the field. Her study of quadratic form also led her to investigate real algebraic geometry as well as complex algebraic geometry and the cohomology theories that are linked to it. She has also got many awards and honors like Shanti Swarup Bhatnagar Award in 1987, Srinivasa Ramanujan Birth Century Award in 2003, TWAS Prize for Mathematics in 2005. Dr. Neena Gupta. Dr. Neena Gupta is an Indian woman mathematician who is an associate professor at the Statistics and the Mathematics Unit of the Indian Statistical Institute, ISI, Kolkata. She was born in 1984 at Kolkata. She completed her schooling at the Khalsa Model Senior Secondary School. She went on to graduate with honors in mathematics from Beacon College, a women's college in Kolkata. For graduate school, she attended the Indian Statistical Institute (ISI), completing a master's in 2008 and a PhD in algebraic geometry in 2011. Even from a young age, she loved maths. She said that although she was not the kind who got full marks in mathematics, but she just loved to solve problems and spend hours doing it. Contributions and awards. Neena Gupta's primary fields of interest are commutative algebra and affine algebraic geometry. Gupta won countless awards and honors for her innovative work in algebraic geometry. She has solved 70-year-old Zariski cancellation conjecture that baffled the mathematicians around the world. She has also got many awards and honors like Inspire Faculty Fellowship Award in 2012, Associateship of the Indian Academy of the Science and the Saraswati Gossip Medal by the TIFR Alumni Association for her work on the Zariski cancellation problem in positive characteristic in 2013, the INSA Young Scientist Award and the Ramanujan Prize from the University of Madras in 2014, Shanti Swarup Bhatnagar Award in 2019.